Now let us see what is relative lowering of vapor pressure. This is a colligative property. As we discussed about four colligative properties in previous video. Okay. Now we will go in detailed manner. Okay. Let us see what is the definition for relative lowering vapor pressure, RLVP. Okay. This is also considered as relative lowering of vapor pressure. Relative lowering of vapor pressure. Now let us see. So while we go through RLVP, relative lowering of vapor pressure, we should know about vapor pressure. Let us see now what is vapor pressure. Okay. Vapor pressure. Okay. Now, vapor pressure can be defined as the pressure accepted by the liquid molecules present in vapor phase on the molecules present in liquid phase when the both phases are in equilibrium. Now let us see the definition. The pressure accepted by the vapor phase molecules on the surface of liquid phase molecules when both phases are in equilibrium. Okay. Now let us see this phenomena with an illustration. Okay. When we take a pure solvent in a closed container, then existence of liquid phase and existence of vapor phase will take place. Okay. So this is considered as liquid phase. This is considered as vapor phase. Okay. So here, when the both phases are in equilibrium, these molecules is responsible for vapor pressure. vapor pressure. Okay. Here the vapor pressure of pure solvent represented as P naught. The vapor pressure of pure solvent represented as P naught. Okay. So now let us check the definition again. The pressure exerted by the vapor phase molecules on the surface of liquid phase molecules when both phases are in equilibrium is called as vapor pressure. Clear? Now let us see what is lowering of vapor pressure. Lowering of vapor pressure. So let us see first the illustration regarding lowering of vapor pressure. So here, as we discussed in case of vapor pressure, if you take a volatile solvent in a closed container, as we discussed prior, the situation is like this. Situation is like this. This is vapor phase. This is liquid phase. Okay. So when these two states, vapor phase and two phases, vapor phase and liquid phase is in equilibrium, then vapor pressure will be exerted. That vapor pressure is equal to P0. Okay, this is regarding vapor pressure of pure solvent. Okay. So when you introduce a non-volatile solute, okay, when you introduce a non-volatile solute B, then let us see what will happen. Here, because of non-volatile solute, B, this B is non-volatile solute. Number of particles of solvent A present in vapor phase will be decreased. Okay. So because of this, as the number of solvent molecules decreases in vapor phase, then vapor pressure decreases. Let us say here the vapor pressure Vp is equal to, here the vapor pressure Vp is equal to Ps. Okay. This is pure solvent. This is dilute solution. Dilute solution. Okay. Are you observing here what is happening? As a non-volatile solute is added to the pure solvent, then the number of molecules present in vapor phase is decreasing because of intermolecular attractions of A and B. Is it clear? So then vapor pressure also will be decreased. Vapor pressure also will be decreased. Now, the vapor pressure can be written as a lowering of vapor pressure, that is a lowering of vapor pressure, and it can be represented as P0 minus Ps, P0 minus Ps. This is said to be LVP, lowering of vapor pressure. Here P0 is equal to vapor pressure of pure solvent, that means before adding non-volatile solute. Ps is after adding non-volatile solute. Then the pressure will be reduced, that is said to be lowering of vapor pressure. Now let us define, based on these illustrations, now let us define lowering of vapor pressure. Okay. Decrease in vapor pressure of pure solvent due to addition of to addition of non-volatile solute, due to addition of non-volatile solutes. Decrease in vapor pressure of pure solvent due to addition of non-volatile solute. Now let us coincide the definition with illustration. Here this is vapor pressure of pure solvent, that is P0. This is because of more number of solvent molecules present in the vapor phase. After adding non-volatile solute, the number of solvent molecules present in vapor phase is decreasing, then vapor pressure also will be decreases. That is said to be lowering of vapor pressure, and it can be represented as LVP is equal to P0 minus Ps. So let us see, we have equated LVP as LVP is equal to P0 minus Ps. Okay, this is LVP, lowering of vapor pressure. Okay, now let us see relative lowering of vapor pressure, RLVP. What is relative lowering of vapor pressure? Here the abbreviation is given, relative lowering of vapor pressure. Now let us define it. Okay. So here the ratio of lowering of vapor pressure, what is lowering of vapor pressure? P0 minus Ps, and vapor pressure of pure solvent. Vapor pressure of pure solvent. P0. Okay. Now let us write the representation of RLVP. Then RLVP is equal to P0 minus Ps by P0. Okay. This is relative lowering of vapor pressure. Okay. So keep in mind, vapor pressure is not a colligative property. Lowering of vapor pressure is not a colligative property, but relative lowering of vapor pressure is a colligative property. Okay, is it clear? Thank you.